Students, we have completed the chapter Thermal Expansion of Solids in our theory classes, and we have started discussing the numericals from this chapter only. Okay, so we have discussed three numericals. You can check out from the PDF also and from the previous videos also. And we will start the next sum, that is it will be your sum number 4. Okay, so your sum number 4 is like this, very important one. It came in many HS exams, previous HS exams. So this your sum number 4 is like this: the difference of lengths of two metal rods A and B is 0.25 meters at all temperatures. If the coefficients of linear expansion of the materials of the rod A and B are 1.28 into 10 to the power minus 5 per degree C and 1.92 into 10 to the power minus 5 per degree C respectively, find their lengths at 0 degree C. Clear? So what is given, students, in the question? Let us see. The difference of the lengths of two metal rods A and B is given. Okay. And this difference is same at all temperatures. Alright. What is the next data given? If the coefficients of the linear expansion of the rods are the two data is given, you have to find out their lengths at 0 degree C. Okay, that lengths you have to find out. Their lengths at what temperature? 0 degree C. Okay. So let's start the sum. So first of all, you have to assume, let the length of the rod A at 0 degree C be L meters. So I'm writing here, this is the length of the rod A at 0 degree C be L meters. Okay. And you can see, students, from the second part of the question that the two coefficients of linear expansion given. So from the two coefficients of linear expansion, you can see that the coefficient of linear expansion of B is greater than that of the A. Okay, what is the value of B? Coefficient of rod B, that is 1.92 into 10 to the power minus 5 per degree C. Okay, and what is the linear expansion of your A, rod A, is 1.28 into 10 to the power minus 5 degrees C. Okay, so you can say that yes, your B's coefficient is greater than that of A, isn't it? So you can assume that the length of B will be what? Length of B be L minus 0.25 meters, isn't it? Why? Because your length of the rod A that I've written on top, the length of the rod A at 0 degree be L meters, and in the question the difference of the lengths of the two rods given, isn't it? So you can say that your length of the rod B will be L minus 0.25 meters. Is it clear? Now, students, since yes, now if the temperature is increased by T degree C, okay, so then what you can write? I'm just writing here, if the temperature increases by 90 degrees C, then the linear expansion of the rod A will be what? A equals to L into, for rod A, the linear expansion will be A equals to L into 1.28 into the coefficient of linear expansion, students, you just check out from the question, into 10 to the power minus 5 into T, isn't it? So this is your linear expansion of the rod A. Now students, you just write down the value of your linear expansion of the rod B. B will be what? This part, that means your L minus 0.25 into 1.92, see the coefficient of linear expansion given already, into 10 to the power minus 5 into T, isn't it? So which will be equal to, okay, you don't have to write the simpler expression of this, just write till here. Okay, so now you have been asked that as the difference of the lengths of the rod A and B remain same at all the temperatures, see the first statement of the question, it's written already that the difference of the lengths of the two rods is maintaining by 0.25 meters at all temperatures, so their linear expansion will also be equal, isn't it? Why? Because the difference of the lengths is remaining same at all the temperatures. Okay, we are just following the question only. So what we can write? So therefore, it's time to equate the two linear expansion of the rods. So let's write L into 1.28 into 10 to the power minus 5 into T, which is equal to, again this B's part, L minus 0.25 into 1.92 into 10 to the power minus 5 into T. Okay,